All right, all right. I turned the recorder on because we were having a serious conversation about math. Okay. Oh, darn it. I forgot to do important things before this started.
Again?
Yeah, again. Oh, jeez. That's okay. Let's see now.
Where's Joey? J-Dog.
I don't know where J-Dog is.
I thought he was like on it. I just really wanted to ask him if he heard me recording yesterday.
Probably did.
Probably didn't watch it yet. That's how I was gonna find out.
Oh yeah, probably not. I just uploaded that recording like a couple hours ago. Yeah, I accidentally, I turned it on today and I was like, what the heck? Like I left the recorder on and it was like a 5-hour video. And like you can just hear like bag noise, like it's like scratching and stuff. I'm like, how did this thing not turn off?
The printer, like it was probably on.
Yeah, I just cut it all out though. Okay, so yeah. Okay, so let's.
Talking about The Office this week. No Game of Thrones.
Okay, so as I was about to say, we're starting on chapter or section 7.3 today. Like I was saying yesterday, we went over the graphing method and the substitution method. Today we're going to go over the elimination method, and then we're going to go over some word problems. So let's begin. Right? So basically, the elimination method, it basically makes use of the addition principle. The addition principle says if you have two things that are equal, A equals B and C equals D, you can add both sides of those equations together and maintain the equality. So you can add both left sides together and right sides together, and you get another equation that is also equal, right? And so we're going to make use of that in this chapter.
In 7.3,
right? Yes, in 7.3. So basically, we use vertical addition, and this is kind of what it's going to look like, except for it's going to have a lot more specific stuff involved. But vertical addition, you just add both things on the left side, A plus C. The equal sign goes in the same spot, and B plus D. So as you'll see when we do the examples, the whole purpose of this step right here, just like substitution, is to get rid of one of the variables. Right? That's the whole purpose of elimination. We eliminate one of the variables. Haha.
Sorry.
No, you caught me. I was about to scroll. You got me. You guys got me.
All right, we're starting with
got my timing down. Yeah. Okay. So suppose I'm asked to solve this system of equations using elimination. Just like we usually do, this first example is like the first step is done for us in this, right? And so this is a prime case for elimination. The reason why is because we have opposites. When we have opposites in both the different equations, you can see when we add those together, those opposites will cancel each other out. And so most of the time in elimination, it won't be set up this nicely. This is a really nice setup. Basically what happens here is the 3 y's go away. They cancel each other out. And then we have 2x plus 4x equals 13 plus 17. And so that gives us 6x equals 30. Then we divide both sides by 6. And we get x equals 5.
So what if both of them were plus 3y? That wouldn't work?
That's an awesome question. No, it wouldn't work right away. Right? And so you'd have to say, well, I don't have opposites yet. So what you would do if you started with 2 plus 3y's is you'd multiply one of these equations by -1. You'd multiply the whole equation by that, and then that would give you the opposites you needed. And I'll show you how to do that on this next step.
Be just like proving it.
No, that was no.
Yeah,
That's,
but what if?
it's a good question because like we always do those super easy setups first, and it's like, well, what if things aren't so easy?
I just feel like you should be able to still.
No,
Like,
well, you
why
could.
not?
Sure, you could, but then you get another equation that still had two variables in it. And so basically, like, your elimination wouldn't have gotten you anywhere. You'd just be kind of, yeah. So like, here, just so that you know what it looks like when you're ready to add vertically, right? This one has opposites. This one is not quite ready yet, right? And so like this one, add vertically, you're ready. This one here, I would want to manipulate it first. I say, well, I need a negative 3x. So what I'd do for this one is I'd multiply both sides by negative 3. And that would give me the opposites that I needed. Okay? So it's kind of like if you don't have opposites, you got to think of a number that will give you the opposites. Okay? So, sorry. Right, and here I'll just show you what happens if I took that to the next step, right? I'd multiply this upper equation by negative 3, and that would give me negative 3y equals, oh, I'm sorry, it shouldn't be a negative 3, it should be a positive 3, shouldn't it? I'm sorry, that's probably confusing. I apologize.
I was just going to be like, if it was negative 3, then the y would be gone, right?
Yeah, yeah. I was just thinking that too. I was like, this is going to work out strangely. So I apologize. Yeah, it should be a positive 3 because that's what we need to make the opposite of negative 3. So then when I multiply my positive 3 and I get positive 3x and positive 6. Right? And so then I'd say, okay, I need to vertically add here. Over on this left side, I'd end up with 6y. Right here, my x's would cancel, and I'd end up with 6y equals 15 plus 6, which is 21. Okay, so that's kind of like, that's the difference, though. That's the main difference,
but
right?
Then we can't, right?
What?
Wait.
And well, now that we're here, right, all we need to do...
anything with that.
Sure we can. We got to divide both sides by 6, and then we have a concrete answer for y. Yeah, and then we just plug it back in. Yeah, fractions still, we get to do that, yeah. You're like, but that's a fraction, and we can't do fractions.
I don't know what's going on with these fractions. I'm still sorry, fractions. You are still valid. Oh my god.
All right, so let's try one of these from the beginning. So suppose we have this system of equations to work with. You can choose whichever variable you want to make opposites from, but it's a really smart idea to choose the variables that are multiples of each other, right? And so if I chose the x's in this case, like there's no, I'd have to multiply one of these by a fraction to get the x's into opposites. Since the y's are exact multiples of each other, I know I can do that with just an integer multiplication. So let's see now. So what I want to do is I want to make it so that this negative 2y becomes a negative 6y, because that's what's going to give me the opposite of the 6y above it. All right, so, so I'm going to go ahead and multiply both sides of this equation by a positive 3. And it should be positive this time. I go ahead and distribute that in, and that gives me 15x minus 6y equals 3 times 14, which is 42 maybe? We'll say it's 42. Okay, so now I have what's going to give me the opposites. So I'm going to rewrite this upper equation down here so I can do my vertical addition. So this one is 3x plus 6y equals negative 6.
I thought you were writing out the answer. Like,
no, not yet. Not quite, not quite. Okay, so now we do our vertical addition, and we see that our y's cancel. Minus 6y plus 6y equals 0. On the left side over here, I have 15 plus 3x. That gives me 18x. over here on the right side, I have 42 minus 6. That gives me 36. Now, just like always, I divide both sides by 18. And that's going to give me x equals 2. So now, I got to go back up and I got to figure out what is y. So this is a little bit more of a pain in these ones, because remember, in substitution, we had always solved for y before, but now we haven't always got, y is not always solved for. So we've got to back substitute this x equals 2 into one of our previous equations and figure that out.
Do the top one.
I agree. I like the top one better.
Thank you.
Okay, so I write out my top equation, then I go ahead and sub in the value that I know x is equal to. So x equals 2 plus 6y equals negative 6. That's kind of weird. So now I have 6 plus 6y equals negative 6. And now if I subtract 6 from both sides, so minus 6, these will cancel, and I end up with 6y equals negative 12. I'll give it a pause because I see D-Money's back there working furiously. Fists of fury. Now we divide both sides by 6 to get that y all isolated, and I end up with y equals negative 2.
I like this section.
Yeah?
Yeah.
Good.
Watch it like, okay, now turn it into a graph. You're like, oh, never mind. I didn't come out.
The great thing about the graphing, if you really hated it,
It's really happening.
well, yeah, it's definitely happening. But you can always like check your work on your graphing with an algebraic solution, right? Like so, even if so if I say, well, solve this system of equations by graphing, and you say, well, okay, I'll throw this graph together. I'm not sure if that's correct. You can go and solve that same system of equations using elimination or substitution to check your results, right? And so if you solve it using this stuff that we're learning now, and you come up with the same result, you can say, yay, I did good at graphing, right?
Wait, so we're not, it doesn't look like we're using graphing in this section.
We're not, but this is equivalent, right? Solutions.
So hard to read your little text.
Oh yeah, no, there's no graphing. Yeah, and so like solving by graphing gives you the same exact solutions that you get by elimination, this method, or by substitution that we learned yesterday. And so you can check your answers with different techniques if you want to.
I'd rather check them with this.
I know. Nobody ever checks their answers in this class. It's crazy. And I don't just mean you guys. I mean like nobody that I've ever had as a student.
No, I don't have homework.
Do you? But not on an exam.
I do.
Do you?
With my calculator. I'm not going to write it down with my calculator. It's so easy to plug in X and Y in a calculator.
It is.
Write it down. It's not like I know multiplication anymore.
All right, so with this one, I don't know. I think I want to choose the x's to make opposites out of. All right, they're exact multiples of each other, and so that should make this easier. So I just note that in order to make...
So we're never going to... I'm going to forget the terminology. The term on the
constant term, this over here?
Yeah.
No, and the reason why is because if we eliminated that, we'd still have two variables and nothing to do with them, okay. Right? We just say, well, that didn't get us anywhere.
X.
Yeah, unless you were really tricky about it and did both at the same time somehow.
Einstein would do it. I'm just kidding. Einstein would take credit for it. I just feel like he's that kind of guy.
He looks like it, right? Dude, he did not figure out relativity. That was his cousin, right? Yeah.
But his cousin was like uglier, so
yeah.
He was like, I'll do it for you.
Gilbert Einstein.
Yeah.
All right, so basically what I'm thinking about here is I'm thinking about a number that I need to multiply this upper x by to get the opposite of 2. If you think about it hard enough, you'll find that that number is negative 2. And this time it actually does need to be a negative. All right, so I'm just going to rewrite my results of that multiplication down below. So negative 2 times x gives me negative 2x, exactly like I wanted. Negative 2 times 9y gives me negative 18y. And then negative 2 times 1 gives me negative 2. All right, so I go ahead and I draw my line out, and I add vertically. 2x minus 2x, that gives me 0. And make sure that you actually are getting 0 on this, right? Like, just because I cross them out every time up here because I chose the right answer doesn't mean you should automatically cross them out on your homework. If these two things aren't opposites, don't cross them out. You got to go back and make them opposites, okay? So now I add the y's together. I have negative 6y minus 18 more y. That gives me a negative 24y. Now I have 10 minus 2, and that just gives me 8. All right, so now I go ahead and I divide both sides by a negative 24. Yep. And like Tyler said, we quit now because it's a fraction.
Yeah.
I like that. I really like that.
I hesitated because I was like, divide the 8.
Yeah. If you try to divide 24 by 8, though, you'll get 3. So this fraction is 1/3. Now we got to plug this guy back in to figure out what x is equal to. So I'm going to use this upper equation, x plus 9y equals 1. And then I'm just going to subtract 9y from both sides, just so that my x is kind of already just isolated. You don't have to do it this way. I just like to do it this way. So now I'm going to plug the y in. Now. So I have negative 9 times a negative 1/3 plus 1. Oh, well.
Yeah, I'm so confused. Don't touch
Okay.
the iPad.
I'm backing up. I'm stepping away from the pad. Okay, and so if you guys are sort of lost as to where we went on that,
Yeah.
I solved the y equals 1/3, and then I said, well, okay, now I need to know what x is to finish this problem out.
Right.
So I took this to upper equation, and I put it down here. And if I wanted to, I could plug y equals negative 1/3 in on this step. But for some reason, I prefer to just subtract the 9y first. So that's what I did. You don't have to do it that way, but you can if you want to. If you want to, you could plug in the negative 1/3 on this step. I just feel like it's easier if when you plug everything in, it's on the same side and you don't have to do any more algebra. But I'm a weirdo like that, so. Okay. So now I have negative 9 times.
Oh my God.
Oh yeah, they took the trash. That's true.
So rude.
They said we weren't responsible enough.
Our one classroom in this entire campus without a smart board, and they take our trash can too.
Right? We're not worthy of technology like trash cans. So this first term, negative 9 times negative 1/3, right? 9 over 3 equals 3, and the two negatives cancel each other out. So I have 3 plus 1 here. And this gives me 4.
Talking, but I didn't see you writing until then.
I was doing this guy here, right? And so negative 9 times negative 1/3, and here maybe I shouldn't skip that. You're right. So for this one, we're looking at a negative 9 over we could call it a negative 3 like that, plus 1, right? So that should make it a little more clear as to why I got that. Turns into a positive 3 plus 1.
See, it's important to do those stupid steps on your notes, because then when you're like have a problem like that, that's not the same thing. And you go back and look, you're like, how did I even get there? Thank you. Thank you.
And
Then you have a bunch of questions on a section from last quiz that you still haven't asked Louis because you're lazy.
Just remember though, this is from chapter 1, right? So like at a certain point, we got to stop doing that stuff. So just I'm bad at skipping those steps. Yeah, I'm bad at skipping those steps, but eventually you got to be able to pick that stuff up, because when you jump into algebra next year, Colleen skips those. You know, like I have a style where you guys might not think this is true, but I over-explain everything.
No, I do.
And so like I get too detailed sometimes.
I only notice it sometimes.
Yeah.
Other times I'm like, please, thank you.
Colleen has a more traditional style that's a little bit more like what you'll experience in upper level classes, which is like, you know, she doesn't necessarily go over all the small details and she'll skip steps. You know, and you've got to fill them in while you're there, and it's just a skill that you pick up.
At it, right?
No, not at all. Yeah, and if you don't, sorry, did you say?
This stuff.
No, you don't have to be perfect at it. Yeah, and you know, if Colleen skips a step in class and you don't get it, like you can still ask her, and she's awesome about explaining it all. But typically, she'll go through the examples and not explain every little step. So that's, you know, it's something that it's a skill that you get as you do more math. Okay.
No, I just know the stuff that she said that should be reviewed for you all in the class above this. I still don't know how to do it. Like, I remember it is ingrained in my brain. I still, like, we are past midway in this class.
Yeah.
We are far from the show, like, far. There was youth in
so
there.
Funny. Oh, they might have been using some different variables that are confusing, right? You know how like I used mu, and like people freaked out about it.
Maybe, but just like this should be like I don't know.
I don't know. All right. So here we go. Let's do some more examples here.
That's what you got to look forward to, guys.
Yeah, and I don't say that to scare you. I just mean like, you know, start getting used to, you know, figuring out those little steps in your head. It doesn't mean it's bad if you know, like you've got to slow down when you figure those out. It means you're still like building your skill up. Like there's plenty of times when.
Keep going. Yeah.
All right.
All right. Yeah.
All right. So you're right. Okay. So so with this one, I say okay. I don't know. Maybe I'll choose the y's, as you'll notice.
Like a negative anything in here, right?
Yeah. Just a -1 would be sufficient.
Well,
so we're going to do that.
One, then we would take out both the variables.
I know, and that's the weird thing, right?
Is that what you're
I think
saying?
you'll notice, yeah, and that's a good point. Yeah, you'll notice that no matter what we do, we're always going to take out both variables in this case because they're the same, right? And so I'm just going to write the results down here of this upper multiplication. So now I have -y plus 3x equals -2. When I do my vertical addition, these cancel, and I have 0 equals -1. What do you think that means?
Prime.
What was it? That's too quiet of a whisper for me.
So the recording can hear it.
Undefined, yeah, or no solutions. Yeah, which means these two lines are parallel. Yeah, remember, yeah, when you come to the end and it's something that just never will be true, no matter what, you can immediately say, no.
But what if we did like a -3?
Try it.
On both sides.
You could try it. You could try it.
How you said it, I'm just like.
Give it a shot, yeah. Oh, you can sit in the student center all day and try it. That's what, yeah, I used to have an awesome student who used to always do that. Like, well, what if we did this? What if we did that? And eventually I used to just be like, try it. Just try it and tell me how it works. All right, so that's what a no solutions example looks like. Let's try something slightly different. So I'm going to try and make opposites. I don't really care. Again, it doesn't really matter on this particular example. I see that 3, all I need to do is multiply it by a +2 to make it into the opposite of -6.
But there's no solutions on this one too.
I don't know if you're correct on that.
Okay.
Try it. No, just kidding. It's like we're about to try. Okay, we're about to try it. I'm all snotty with it. Try it. All right, so 2 times +8 gives us +16x. 2 times 3y gives us +6y. And 2 times 4 gives us positive 8. Yeah. Yeah. So, so everything cancels. Boom, boom, boom. And we get 0 equals 0. What does that mean?
Prime.
Yes, it means 0. That's true. Prime. Not quite. So remember, when we come up with something that's always true, that means that there are infinite solutions to this.
No. Okay.
And it basically means like it doesn't really matter what you plug in for x or y in this system of equations. As long as it's on the line, it'll be true. So there's an infinite number of solutions. And we could kind of see that because we notice that this equation right here that we chose to multiply is an exact multiple of the other equation, which means they're dependent. It's that definition we went over yesterday. And if they're dependent, that means they're the exact same line. Okay. Okay. Let's see now. Is this the example I want to do? Yes, it is. It is. And actually, this part is incorrect here. There's a different example. So let's do this example. So this example is, it's kind of like a cost for services example, you might say. I mean, it's the type of example where they like outline the cost for a service. There's usually a base rate and then a cost per minute or per text or something like that. So this problem says, Sydney plans to spend 1 month in Ireland as part of an archaeology internship. Her cell phone carrier offers 2 plans that fit her needs while overseas. The silver plan costs $60 a month plus 50 cents a minute. We're just going to write that down. Silver equals $60 per month plus 0.5 times, we'll say x. And we'll let x be the number of minutes. Does that make sense?
Yep.
Okay. So now we're going to say the gold plan. That costs $120 a month plus 35 cents a minute. Okay, so gold equals 120 plus 0.35x. Now they say, for what number of minutes will the cost of the 2 plans be the same? So this part's the part that's a little bit weird in this, and you might just have to memorize what I do here. There's not a whole lot of examples like this, but there's a few. So what I do here is I'll just erase silver and gold, and I'll say, well, if we're wondering what values of x make them cost the same, I'm going to set these equal to c, some cost.
Wait, you erased it.
What?
Oh, never mind.
This top one is silver, sorry.
I don't know, it literally says gold.
All right,
What
so.
comes after silver, though?
So now with this one, right, to solve this system of equations, we have our system. This is an easy opposites, right? We just say, well, we've got our variable right there. Let's just multiply one of these by a negative. So I'm going to multiply the lower one, or well, yeah. I'll multiply the lower equation by a negative, boom, which changes the c to negative, the 120 to negative, and it also changes our little 35 cent to negative. Okay, add them together, and I get 0 equals negative 60 plus, I think, 0.15x.
Wait, why did you change to a minus?
Because I multiplied this lower equation by negative 1.
Okay.
Yeah. Yeah, and so basically I just switched all the signs so that I could eliminate the c from the variable, or from the equation. Okay, so now I have an equation to solve. It's only got one variable in it, which is good.
Wait, why are they both C?
Because the problem says, what number of minutes will these 2 plans cost the same? Right, and so I said, well, let's make up that cost. Yeah, we don't know what the cost is, but we know it's the same, so I set it equal to C. Then I multiplied this lower equation by -1 so that I could do my elimination. So now, on this equation that I have here, I want to add 60 to both sides so I can isolate my little 0.15x. So I have plus 60 plus 60. That gives me 60 equals 0.15x. And so don't be scared to divide this just because it's a decimal, right? It's totally fine to divide this and punch it into your calculator if you want. So 60 divided by 0.15, that gives me 400. So 400 minutes would give them the same cost on each plan. Now, actually, if we read the instructions to this close enough, they don't ask for the cost of the plan, right? It just says, for what number of minutes will the cost of the two plans be the same? So I don't need to find C if I don't want to, and I don't. But yeah, just remember that, especially for the word problem versions, if it only asks for one of those variables, you only have to solve for one. And it might be a good idea to read that because what if it only asks for one variable and you solve for the wrong one, right? Then you got to solve for both anyway, so pay attention to that. All right, so x equals 400 minutes would be the answer to that beast. Darn it, I don't have the page number written on there again. But in your chapter, there is a summary of the types of solution for the types of solutions for systems of equations. And so this is a summary where you get kind of like the strengths and weaknesses of graphing, substitution, and elimination. Just remember for your exam, I'm going to have you solve one by graphing specifically, so you got to know how to do that. But then in the exam, the rest of them you can solve by either substitution or elimination. And so if you're kind of hazy on one of those, it's going to be less important. But unfortunately, I'm sorry about this, but graphing's definitely going to be on there. It's kind of a different solution type, so it's kind of required at this point. All right. Well,
How to do it, that's all that matters.
all right, so on to 7.4. We are now leaving 7.3 and moving on to 7.4. For 7.4, these are all word problems, so I tried to make sure that I did word problems that were different than the ones in the chapter so that you had more examples that you could look over later.
What?
Yeah.
And then we're gonna write down all the words for our notes.
Maybe. I'm sorry, I know, that's terrible, that's terrible. I hope.
To be like, oh, this is question this one, so I don't have to write it, and then I understand what's going on.
I think I did that for a few of them. For a few of them, you can just write where they, like what number they are in the chapter to reference them. But I think there's a few more that I was mean on and I didn't do that.
40 minutes.
It's true. But
Rod's gonna be here.
but oh, is today's the day? Okay, so I need to hurry. But just remember, like if you're at a loss on your homework and you're like, well, this isn't quite what we did in class. There are different examples in the book, and they go over them in painstaking fashion. Like they go through the whole 5-step solution, what is it, problem-solving process, so you can.
It confuses you, it makes you want to commit suicide with paper.
Yeah, I don't personally. I'm not super rigorous on that 5-step process. It's more confusing than it's worth for most of the time. So.
I
Yeah.
feel like I just want to watch this part of the video at home and then write it down.
You could just write down the basics if you
No,
wanted
I'm
to.
just gonna do like the problem, and then I'm gonna go look at the video.
That's not a bad idea.
Yeah.
That is not
So
a bad
please-
idea.
Please post it.
Okay.
Are you recording?
Yeah, I am actually. I am. All right. So example 1. In a game of American rules football, the Seattle Seahawks scored 5 times in a combination of 7-point touchdowns and 3-point field goals. The number of points resulting from these field goals and touchdowns was 31. How many field goals and how many touchdowns did the Seahawks score? So this type of problem, I call it a total value problem. Total value problems, they usually have some action or event that is like kind of basic, and then something that comes from that event. And so in this one, we have the number of times a team scored, and then we also have the points resulting from those scores. And so that's what you make your two equations from on these types of problems. So the first equation is almost always gonna be an overall number of items or actions, right? And so for this particular problem, we would say let touchdowns be represented by X, and we'll say let field goals be represented by Y. So the first equation, we'd say, well, they had 7, let's see now, they scored 5 times. So we'd say X plus Y equals 5. Right, so that's kind of like your basic equation. The number of times you scored, that's it.
What? How about?
What? Did something go wrong?
Yeah.
So basically, this problem says the Seattle Seahawks scored 5 times. Those were a combination of touchdowns and field goals. So we said X plus Y equals 5. The number of touchdowns plus the number of field goals equals 5.
What about 31?
That's what I'm about to get to. Good question. So the second equation, the second equation counts up a total number of points or dollars according to each action or item, right? And so we say, well, the touchdowns, those are worth 7 points each, right? So we say 7x plus the number of points resulting in field goals, which is 3 times the number of field goals, so 3y, equals the total number of points, 31. So there's our other equation.
Wait, where's the 7 come from? The 7 is the touchdown, the 3 is the goal, and the 31 is the total.
Good.
Did it say that?
It did.
Yeah. Oh, okay.
It did.
I couldn't find it.
It said that, and it's also just like, you know,
no.
it's like the rules of
Highlighted.
American football.
Okay. I got confused for a second too, but then I figured.
I'm sorry.
It's literally
I'm
highlighted,
sorry.
and I'm like, I can't find it in the paragraph.
Okay, and so so now we have our two equations, right? And so let me just write them next to each other. So I have x plus y equals 5, and 7x plus 3y equals 31. So now I'm gonna make opposites out of my y's. So what I need to do is I need to multiply this lower equation by a -3. When I do that, I end up with -3x minus 3y equals -15. Okay.
No, oh, just kidding, sorry.
Now I'm going to write the other equation down below here so I can do my subtraction. So 7x plus 3y equals 31. Okay, now that I have my opposites, I draw in my addition line and I cancel my y's. And I have 7x minus 3x. That gives me 4x. And that's equal to 16. Okay, so now I divide both sides by 4. And I get x equals 4. Right? And so this is a nice one because if x equals 4, and we know x plus y equals 5, what does y equal to? Yeah, y is just equal to 1 here. Okay, so the Seattle Seahawks on this particular night scored 4 touchdowns for 7 points each and 1 field goal.
Garbage.
Garbage, right? They probably lost anyway.
Yeah.
Just kidding. I've had a few football fans in my class in the past, and they're like, "What do you mean American rules football?" And I'm like, "Well, you know, it's not real football. Like, it's only in America. Like, real football is like soccer." They get real mad.
Soccer is the sport for people who can't play sports.
What?
No, that's the only sport I'm good at. Like, I'm good at it.
Dude, if any sport would be like for non-athletes, it'd be like bowling, right?
Yeah, I only say that to my boyfriend because he was a soccer coach. He gets really mad.
That's funny.
Now I have to say it.
You almost got me on that one.
I know.
What?
No, I say it because I'm the only one who, like, that's the only sport I actually can do. And I never tried.
I love soccer.
I just remember being in 6th grade and I like dominated in soccer and I was like, I'm a ballerina. Like, that's the only sport I can. But I was one of the best soccer players in my 6th grade.
It's awesome. Okay, so we have a UAS student. His name is Jerry McGillicuddy. Jerry took 8 courses over the past 2 semesters, right? So he took 8 overall courses. Each course Jerry took at UAS was worth either 3 credits or 4 credits. He earned a total of 26 credits.
Wait, what? Oh, 2 semesters.
Yeah.
Wait, how?
No, he's not that crazy. Yeah, yeah. How many?
I'm getting there. I'm losing my mind.
Yeah, the most I ever took was 16, and I was like, no, that's not fun. I don't want to do that anymore. Okay, so just like our normal strategy goes, the first equation is an overall count of numbers or items, right? So we're just thinking of how many classes did Jerry take. So we're going to say, let 3 credit equal X, and let 4 credit equal Y. So they say Jerry took 8 courses. So what should our first equation be?
It could be.
And specifically, what?
I really had it and I was wrong.
What equals 8? Right? X plus. You're correct on that. Yeah. Thank you for that. For those who didn't hear at home, somebody just said 4 times 2. That was good stuff. All right, so the first equation has to do with the overall number of classes, right? We don't put credits or anything like that in there. The second part of the equation is all about the credits. So if it's 3 credits per class that we take X.
4x equals 26.
Boom.
Okay,
3x
right then.
plus 4y, careful,
Oh.
equals, 26.
That was the one I was too scared of. Wait, that's wrong.
Do you guys kind of see how this pattern works, though, right? Like, the first equation is always basic. The second equation you can consider, like, the modified equation.
I mean, I guess I see it.
Yeah, I know you see it.
Yeah.
You're good enough at math. You see it. Okay. So now I want to make opposites. I'll just choose the x's. It doesn't really matter which one of these I choose because they're both multiples of each other. I'm going to multiply this top equation by a -3. Right? And that's going to give me a -3 out in front of this x, which is going to be the opposite that I'm looking for. So I'm going to write my results down below here. So I have -3 times x. That gives me -3x, just like I wanted. -3 times y, -3y. Oh, easy. -3y. And that is equal to 8 times -3, which is -24. Yep, what's the deal with that? Okay. Now we do our vertical addition, right? 3x minus 3x. We did good on our opposites, so those go away. Then I have 4y minus 3y. That gives me a plain old y. That's convenient. And I have 26 minus 24. So y equals 2. And if we just look at our original equation, the basic one, if x plus y equals 8 and y equals 2, we can see that x must equal 6. So McGillicuddy took 6 3-credit classes, and 2 4-credit classes. How you guys doing on these total value problems? They're not terrible, right? Just, yeah. Yeah. Is that, you like my solution?
I take 4 credit classes, so, and I'm only failing one of them, but the teacher don't put that in the grade book, so it was really good for me.
Okay, so let's see now. So actually, so that I can get to the mixture problems on time, I'm going to skip over the last total value problem and come back to it if I have time. So mixture problems tend to be like, if you ask any algebra student about mixture problems, most of them will say, people hate these. yeah, people hate mixture problems. And what I'll say is that if you basically remember how to set up the equation in this table, the rest comes easily. All right, it's just setting it up in the equation that is the pain. So maybe I should skip that so I don't confuse you guys. Good idea. Elaine can help you with that. Yeah, she absolutely will. So you'll see, and I don't need to say all that, but you'll see that in these mixture problems, when we come up with our equations, it's going to follow the same kind of pattern that the total value problems did. One equation will have to do with like a total volume or total weight, and then the other one will have to do with the total percentage of chemical or the total value in dollars or something like that. And so there'll be a basic equation and a modified equation. Okay, so for this example, we have Michelle and Gary or Jerry, I don't know which, mixed decaf Sumatra coffee costing $14.95 per pound with regular Sumatra coffee costing $13.95 per pound. Last month, they made 8 pounds of the blend for $118.10. How much of each type of coffee did they use? Okay. So this is my table, and I don't have it. Let me just draw it out so you guys can see see where the lines are. So your tables with mixture problems should always look like this. The top row will be a total amount or something like that. The middle row would be a multiplier, and the final row is the chemicals or cost of this stuff. So in the first row, we just put exactly what it says, so the total amounts. And so let's create names for our variables here. So we'll say decaf Sumatra. All right, we'll say let decaf equal X, and let regular equal Y. Okay, so then when we fill out our table, our total amounts of type A, actually, yeah, I'm on the right track. So our total amount of type A will be X, total amount of type B would be Y, and the total amount of mix is what they mentioned in the problem, right? And so in the problem they said, we want 8 pounds of mix. So we put 8 here. Sorry about this table. I need to rework that. Now,
I like the little bump.
yeah, gives it personality, huh?
Yeah.
So now in the multipliers column, we put how much a pound of each of this stuff is worth, right? And so X was a decaf. It said up here the decaf was worth $14.95 per pound. So 14.95. The other type of coffee, that costed $13.95 per pound.
They're really not getting our wholesale prices, right?
So this is the weird part about this particular problem. This particular problem is a cost problem, so they don't actually give us a multiplier for the mix. They just give us the final value. So we write the final value down here, 118 0.10. So now finally, to finish this table off, to get each of these entries, we just multiply what's above. So I have x times 14.95. That gives me 14.95x, and then 13.95y.
X times 14.95, I don't know.
Depends on what x is.
Get out my calculator.
You're like, yeah, I forgot my times tables. All right, so now that we've filled out the table, we go to create our equations. And this is where, like, if you know how to fill out the table and you can remember how to do all that, there's a lot of steps to that. The rest is easy. So the first equation, we sum across the top line. X plus y equals 8. The second equation, we sum across the bottom line. 14.95x plus 13.95y equals 118.1. So there you go. And then we just solve the system of equations, right? But to set up, to complete a mixture problem, I would maybe just memorize what these tables look like and how to fill them in. So now that we have our two equations, you guys you'll notice that these problems especially are, these are best to do with elimination, I feel like. So what I'm going to do is I'm going to make opposites out of, let's just say the x's. So I'm going to multiply this upper equation. I haven't done one quite like this before, right? Notice how there's a weird decimal out in front. I just multiply it by negative 14.95. Right, and you'll see that's going to give me the opposites that I need on my x variable. So I'm going to write my results down below the other equation, and I'm going to have a negative 14.95x on negative 14.95y, and then something else. And this one gives me 119.6, and that's a negative number. Yeah. So, all right, so now our 14.95x's cancel out. I end up with just a negative 1, right? Right?
Yeah.
Yeah. Right? I'm like confusing myself up here with that one. Okay, and then we have 118.1. Oops. This one gives me negative 1.5. So now I just I divide both sides by a negative 1, and that will give me y equals 1.5. Now I just got to go back up and solve for x, and then I'm done with this one. So I have x plus y equals 8. So I'm just going to rewrite that down here. X plus y equals 8. I'll substitute the y in on the first step this time, so nothing weird happens. So x plus 1.5 equals 8. And if we subtract 1.5 from both sides, we end up with x equals 6.5. So when we go all the way up to our original problem, we say, well, what the heck was x equal to in the first place? X was decaf. So we'd say to make this desired mix, we would need 6.5 pounds of the decaf coffee mixed in with 1.5 pounds of the regular coffee. And then you'd get your desired mix for the exact cost that you wanted.
Is this from in the book?
This is a question from in the book. Yeah, I don't remember if this one's actually in the chapter, though.
What's your problem?
One that would be in the chapter, though, we could do this one. This might be... What's that? Go back? Oh, sorry. Wait, where was I?
Goes back to
Right here. Here we go. Okay. Right here. Okay. Yeah, so I've got one example coming up that's straight out of the homework.
Okay.
So you won't have to write it all down.
Straight out of sack.
You know what I should do is
Okay.
I'll remember for next semester when it's too late for you guys. I should just get a printout of all those problems and just give them to you guys at the beginning of this class. So you don't have to write all that stuff.
I think about that.
Well, not all these problems, just all the word problems. Yeah.
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 Yeah, good luck next class.
Good luck to you guys.
Yeah.
All right.
Get blared out by Rod.
So this is number 37 on page 464. Don't think it's a number from your homework. And so just notice before we begin here, the last one that we did was about stuff that was worth money. And so that was a mixture problem that dealt with price or cost. This is a mixture problem that deals with percentage of a chemical. So Mallory has a bottle of Calm Morning Fragrance. That is 3% lavender essential oil. I know, lavender's so gross. They also have a bottle of Relaxed Evening Fragrance. That is 1% lavender essential oil. They want to know how much of each of these do they need to mix to get 100 milliliters of Balanced Day Fragrance. That is 1.5%. Okay? So they want to mix a 3% and a 1% to get a 1.5%. So let's...
Just go on Amazon.
They could, but somebody's got to make it for the people who buy it on Amazon.
Free shipping,
Right? These mixture problems are probably one of the more common applications.
Have factories or an Etsy and they know how to do it.
Not all the time. I used to. So I have a.
I'm getting so mad.
No, I have a cousin who, when they had the first essential oil craze, it was over 10 years ago. She was what do they call it? A Wicca?
No.
Wiccan? Yeah, she was a Wiccan, and so she did all this essential oil stuff and sold it to all the rich people down in the valley and made a killing off of it.
People are still doing that.
Yeah, but she just did it in her basement.
Yeah.
Now they do have factories who do all this stuff, but back then they just mixed them all themselves, and
She was probably the age that didn't know how to Google.
she did great with it. They bought it. All right, so let's create our table for this stuff.
My mom didn't know how to Google. How do I know this? With her iPhone.
It's got the iPhone in the hand.
Yeah, she's like, how do I download the Alaska Airlines app? She's like, I don't have an iCloud.
I don't have an iCloud.
You know, she literally said that. And then I go into her iCloud email. She's like, so I did those. Literally cannot have an iPhone.
So since we're dealing, this stuff is volume instead of pounds, right? The last one we were talking about pounds. Now we're talking about total volume. The middle the middle row is multipliers, and the bottom will be pure lavender. Okay, across the top, we always list the things that we're mixing and then the mix itself. So this first column could be Calm Morning Fragrance, and I'm just going to put a little 3% down here. The second column, that could be Relaxed Evening Fragrance. That is 1%. And then finally the last one will be my mix. And that one, I want 1.5%. Okay. So now I designed my table. I just need to fill things in. I'm just going to call the total, I'm going to call the volume of the calm morning fragrance X. I'm going to call the volume of the relaxed evening fragrance Y. So they already told us how much they want for the mix. They want 100 milliliters. And just in case you guys are worried about it, I'm not a stickler for units. You know, put the milliliters in there if you can, but if you're not sure about units, it's okay. So now I fill in the multipliers column, and when we deal with percentages, the multipliers are always the decimal form of the percentage, right? And so this first one is 3%, so my multiplier is 0.03.
I thought, oh, just kidding.
You're thinking of 30%.
Yeah, I was
Yeah.
like, there's so many numbers in that.
Yeah, and be careful, right? Because that's one of the most common mistakes on mixture problems is called 3% of 0.3 instead of a 0.03.
Well, either way, 30% is like 0.33333333.
No, 30% is just 0.3. You're thinking of 1/3.
Oh, yeah.
Yeah.
Yep.
So,
Welcome to math.
so with the relaxed evening fragrance, my multiplier is 0.01. And then for this one, they don't give us a value to put in for the pure lavender. Instead, they give us a percentage. So we actually do use a multiplier on this one, and it's 0.015. So remember, to create the entries in this lower row, we just multiply the entries above. So this gives me
Multiplication table.
0.03x, 0.01y, and then I actually do the math on this column. I say, what is 0.015? Oh, it's 1.5, I already know. Yeah, well, I'll do it anyway. So 0.015 times 100, it is 1.5.
How do you already know that?
Well, because if you just, it's like 1.5% of 100, right? Like, it's when you take a percentage of 100, you just get exactly what the percent is.
Getting percentages of 100 all the time. That's what I want to know.
Why I teach math.
Yeah.
All right, so now we're ready for that, to take that next step. So what we do is we sum all the way across the top for our first equation. X plus y equals 100. And then for our second equation, we sum all the way across the bottom. 0.03x plus 0.01y equals 1.5. So you can see, like, after you figure out how to fill out that table, all you need to do is sum across the top and sum across the bottom, and you have both your equations. And just so that like we're aware of what we just did, the total volume, right? This equation on top, x plus y equals 100. This is an equation dealing with volume. This equation on the bottom, this one ignores the volume and just deals with pure lavender. Right? Ignores the rest of the volume, just pure lavender. Yeah, and it really is saying, like, well, if you have X milliliters of the CMF, then 0.03% of that is pure lavender. And then if you have Y milliliters of the relaxed evening, 0.01 of that is pure lavender, and that equals the pure lavender that must be in the final batch. And so that's the logic of that lower equation that we're creating. So this is, oh, actually, I almost forgot that we're out of the elimination chapter right now. I keep using elimination. Don't forget, we can use substitution on these if we want. Do we want to, though? Not really, not on this one. So remember, substitution, if I wanted to use substitution on this problem,
Oh, it's right here.
I would solve for one of these variables. Yeah, it's in there.
It's in my notes.
I'd solve for, let's say, x, and I'd say x equals 100 minus y, and then let's just do it. Let's do that. We've done elimination all day today. We can do a little substitution.
I already got it started.
It's too late. Too bad. So, and just so you know, like when we're doing mixture problems, substitution is usually not the most efficient way to go. It's not terrible, but it's not the most efficient. To me, elimination is efficient with these types of problems. So I solve for x over here. Now I'm going to plug 100 minus y in for my x right here. So that gives me 0.03 times 100 minus y plus the stuff that was already there, 0.01y equals 1.5. Right, so remember, if that threw you guys for a loop, we're not doing elimination on this one, we're doing substitution. And I just took this stuff, 100 minus y, and substituted it into the other equation. So now I go about solving this thing. 0.03 times 100 is just 3. 0.03 times y is times negative y is negative 0.03y. I'm adding that to 0.01y, and it's equal to 1.5. So let's see now. I got to combine my y's. So I'm going to end up with 3 minus 0.02y equals 1.5. If you're not comfortable with decimals yet, the mixture problems will definitely force you to be that. So now, yeah. So now I'm going to go ahead and subtract 3 from both sides. So minus 3. That's going to allow me to isolate my y's. So I have negative 0.02y equals negative 1.5.
Did we divide by negative, multiply by negative 1, huh?
No. We divide by the. Oh, did you mean? I think we meant the same thing. We divide by the coefficient, right? Which is kind of like multiplying by a reciprocal. I'm sure that's what you meant.
I also hate doing that, by the way.
And I'm going to do this in my calculator because why not? 1.5 divided by 0.02, and we end up with 75. All right, so y equals 75 in this particular example. Let's go up and see what x has to equal.
Wait, how did it get so big?
I don't know. Oh, decimals, that's how. Those things explode if you're not. So if x plus y equals 100 and y equals 75, x must equal 25. So there we go. So we would mix 25 milliliters of, let's see what we labeled x, 25 milliliters of the Calm Morning Fragrance with 75 milliliters of the Relaxed Evening Fragrance to get 100 milliliters of the Balanced Day Fragrance. So there you go. Any questions on those? If you reach the mixture problems tonight and you just want to pull your hair out, you're not alone. These are tough, okay? So don't feel like, you know, you're, especially you, D-Money, don't get down on yourself. I know you can. Yeah, so okay, guys, thank you so much for your patience. I'll be doing more of these on the next lecture. The next lecture, we basically go over chapter 7.4 again, because word problems are important. So we're going to go over all this stuff again on the next lecture with different problems and things, okay?
Okay. Wait, so we don't have to do the homework yet?
Now you got to do the homework.
Oh. That was a really nice try.
That was good. That was good. Yeah.